Have you ever just stared up at the night sky and wondered what's really out there? I mean, really out there, in the deepest, darkest corners of the universe? Well, today, we're going to take a one-way trip to find out. We are diving headfirst into one of the cosmos's most terrifying and fascinating creations.
So let's just ask it. It's the ultimate cosmic question, right? The stuff of science fiction and, frankly, nightmares. But what does the actual science say what happened to you? Let me tell you, the answer is way weirder and more horrifying than you can probably imagine.
Okay, so first things first. What exactly is a black hole? It's not really a hole like you dig in the ground. Think of it as an object with so much stuff, so much mass, packed into such a tiny space that its gravity just goes off the charts. It gets so powerful that it literally bends and breaks the fabric of space-time around it, creating this ultimate trap. Once you're in, there is no getting out. To really understand what it means to fall into one, you need a map of the territory. A black hole isn't just one thing. It's got layers, kind of like an onion. Each layer gets you closer to the center and a whole lot closer to a very bad day. So let's take a tour of the landmarks on our little journey. Our trip starts way out at the accretion disk. This thing is a gigantic swirling pizza of gas and dust heated to millions of degrees. It glows brighter than entire galaxies. If we survive that, we pass through the photon sphere. This place is just bizarre. Gravity is so perfectly balanced here that light, actual photons, gets trapped in orbit circling the black hole forever. And then we get to the famous part, the event horizon. It's not a wall, it's not a surface, it's just an invisible line, the point of no return. You cross it and that's it, game over. Your final destination? The singularity. A single point with basically infinite density where, well, all the rules of physics that we know and love just completely fall apart.
All right, deep breath. We're doing it. We've passed the outer regions, and we're about to cross the event horizon. This is where things get really weird. And, not in a fun way.
The force that's about to tear us apart is called a tidal force. You've actually felt this. It's what causes ocean tides on Earth. But near a black hole, it's amplified to an insane degree. Basically, the gravity pulling on your feet will be so much stronger than the gravity pulling on your head.
And that difference in pull leads to, well, this. And yes, spaghettification is the honest-to-goodness scientific term for it. Your body would be stretched longer and thinner and thinner and thinner, just like a piece of spaghetti, until you're literally pulled apart into a stream of atoms. It's a pretty gruesome way to go, all before you even get close to the center.
So you think being turned into an atomic noodle is the weirdest part? Oh, we're just getting started. A black hole's gravity doesn't just mess with space and matter, it shatters our whole understanding of time.
This right here is one of the wildest parts of Einstein's theory of relativity. The closer you are to that intense gravity, the slower time moves for you compared to someone far away. So let's say you could somehow survive and orbit just outside the event horizon for what feels like 1 hour. If you managed to get back to Earth, you'd find that thousands, maybe tens of thousands of years had passed. You would literally become a traveler to the far future.
So our imaginary journey is over, thankfully. But the story of black holes is so much bigger. They aren't all created equal. Out there in the cosmos, there's a whole zoo of these monsters, and they come in all sorts of shapes and sizes.
You've got your stellar black holes, which are pretty common. They're born when a really big star dies and collapses in on itself. Then you have the supermassive ones. These are the undisputed kings, the titans hiding in the center of almost every galaxy, including our own Milky Way. We're talking millions or even billions of times the mass of our sun. Then there are these mysterious intermediate ones that we're still trying to figure out, and even some theoretical primordial ones that might have popped into existence right after the Big Bang.
Now, the cool thing is, this isn't just old science from a textbook. Our whole understanding of these things is changing, like right now. What we're learning is rewriting everything we thought we knew about the universe.
And I'm not kidding. The year 2025 has been absolutely revolutionary. Thanks to incredible new tools like the James Webb Space Telescope, we're getting a look at black holes that we could have only dreamed of just a few years ago. Take a look at this number, 36 billion. Just let that sink in for a second. What on earth could that be? That is the mass measured in suns of the biggest black hole we have ever laid eyes on. Our sun is 1 solar mass. This thing is 36 billion times bigger. It's not just a monster, it's a cosmic leviathan on a scale that's almost impossible to comprehend. And it didn't stop there. 2025 has been a wild ride.
The Webb telescope found a black hole from when the universe was just an infant, which totally messes with our theories about how they form. We figured out that our own galaxy's black hole is spinning almost as fast as physically possible. We even spotted a rogue black hole shredding a star out in the middle of nowhere. And get this, 2 supermassive black holes eating the same galaxy at the same time. The pace of discovery is just breathtaking.
So they're born from death, they consume everything, and they warp time itself. It really seems like they'd last forever, right? But do they? The final chapter in the life of a black hole is maybe the most mind-bending part of this whole story.
Thanks to the absolute genius of Stephen Hawking, we have a theory that black holes aren't totally eternal. Because of some really weird quantum physics happening right at the edge of the event horizon, they actually leak a tiny, tiny bit of energy. We call it Hawking radiation, and it means that they are slowly, and I mean incredibly slowly, evaporating.
So how slow is incredibly slowly? Well, for a normal black hole to fully evaporate, it would take about 10 to the power of 78 years. That's a 1 followed by 78 zeros. It's a length of time so gigantic that the entire age of our universe, from the Big Bang until right now, is basically just a blink of an eye in comparison.
And in the end, maybe Einstein put it best. These things are where our understanding of the universe just stops, where the rules of reality break down. They are the ultimate cosmic question mark, a sign that no matter how much we learn, the universe will always have another, deeper mystery waiting for us. Makes you wonder what else is out there, doesn't it?